following video tutorial is intended for Stage 6 Software Engineering Year 11 and 12 syllabus in New South Wales for the syllabus section on programming fundamentals. So the dot point today, apply computational thinking and algorithmic design by defining the key features of standard algorithms, including sequence, selection, iteration, and identifying the data. It's embarrassing the bell's going in the middle of this video tutorial. Please enjoy that. Okay, here's where we're going with this, and this is what we're talking about. So we were looking at systems. Systems are composed of data being manipulated and transformed, hardware, storage, and logic. What we are focusing in on in this dot point is logic. Logic, step 1, step 2, step 3, step 4. What most of logic is just a straightforward procedure. However, think that through. Say I wanted to, our role example for Compass, go and look up the first person on the roll and see if they have any detected information that could possibly be helpful. My classroom role doesn't have one person. I need to repeat the same task for every single person on the roll. So, the procedure might be read the first entry in, look up the form group, scan through that form group's class role, see if there's any detected information. If there is detected information, display it. If there's not, don't display nothing. While there is even choice within that, that would have to be repeated. So at certain points in logic, I have to do one of two things. I can't just do step 1, step 2, step 3. I either have to repeat or I have to make a choice. That's what control structures are. They allow for the control and flow of logic by either allowing for a repetition or a loop or allowing for some kind of choice or a selection of a particular pathway. The words that will be used from now on for choice is selection, and then the idea of repeating or looping will be iteration. So selection control structures allow for a choice. The most common are if-else statements. There is the concept of switch case statements, which are written differently depending on the programming language that you're looking at. They allow developers to control and make a choice. If the following circumstances exist, execute this line of code, otherwise execute another line of code, or in a lot of circumstances, if this exists, execute this line of code, and if I don't meet those circumstances, I just skip that block of code entirely. The question you need to ask yourself when working out is a selection control structure appropriate is, does my logic need to choose whether or not to execute something? This is what an if-else control structure looks like. I can write it in two different ways. I can write it in pseudocode, and we're going to get into this lots, and I can also write it in a flowchart. You non-negotiable need to get your head around the rules for writing pseudocode. If it makes more sense for you to also put it into a flowchart, you can, but we primarily use pseudocode in the first instance, and then a flowchart maybe in an example that requires you to convert it into pseudocode or as something supplementary. While you do kind of have to have your head around both of them, it's the pseudocode that's really important. This is the layout for a selection if statement. If in capitals, condition. Now that condition might be if the temperature is less than 20, if the first name equals true, like they've put in a first name, whatever it particularly is. So if condition, then, and then you can put as many lines of processes in here as you want. Usually it's 1 or 2 because you only want to execute 1 or 2 things because we keep everything separate. But if condition, then as many lines of processes as you want. End if. You start an if, you end an if in pseudocode. You will find that when we move into Python, you start an if, but because people who made Python are lazy, you never end it. Don't ask me, I didn't make the rules. You can also do it as an if-else style statement. So the first one is used if you want it to execute based on a condition, and then if it doesn't meet that condition, it's just going to simply ignore and go, oh, okay, I don't meet that. Let's skip around and continue with the rest of the code, assuming there's more code under here. This if-else statement actually says, okay, well, if you meet the condition, do this. Otherwise, I'm going to give you a really specific path. Yeah, I'm going to give you a really specific path. I'm going to give you a false alternative, and you're going to do something else if you don't meet that condition. So you'll see here the triangle for the condition in these flowcharts. If I want it to do something if it's true, and I want it to do something specifically else if it's false, I use an if-else statement. If I just wanted to do it if it was true, or I could flip it the other side if I wanted to just do it with it's false, you can see here in this diagram. If I can do it one or the other, yep, I can just do it as an if and if statement. What it'll mean is if the other opposite side, either true or false, is met, it just kind of continues on and goes out and it doesn't actually execute anything. What happens if I want it to do multiple things or multiple checks? This is called a nested if. Okay, so if condition A is true, then I'm going to do that process. If it's false, I'm then going to check for condition B. And then I'm going to check for condition C. You can see this is inherited as you go down. So if condition 1 is met, then do that process. Else if condition 2 is met, then do that process. Condition C is met, do that process. Else do process 4. So you can see how it's nested within here, allowing me for some choices. And we're going to look at when I would use a nested if statement. The last one that isn't actually used in Python, and I'll show you the syntax for how you do a case statement, is when I have one expression and multiple pathways. Think about a grade. You have a mark go in, and then it has one of 5 choices. That's a really good example for something that would be a case statement. So the grade goes in, and if it's A, assign A. If it's between, this range, 80 to 100, assign an A, 79 to blah, 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 assign a B, and so on and so forth. Yeah? That would be a case statement. Now, in Python, which is a programming language we're going to predominantly use, the word case isn't used, but when we get to it, I will show you the syntax. The next type, so they're my choices. If I need to let my code make a choice whether or not it executes something and what that something is, it's a selection control structure or a choice. An iteration control structure allows for a repetition. Does my logic need to repeat a task or an instruction? If the answer is yes, then I'm using an iteration. Here's what these iterations could look like. A while loop. This process here, or in the graph form, this process here, will keep on looping and will keep on repeating while a condition is true. While password equals false, keep on repeating the process for asking them. I want to keep on doing that. To go back to our compass example, while I'm not at the end of the list, keep on loading the next name into the search to find the form group to pull down the detected information. You'll notice if I go back to the language on pulling that detected information down from compass, within that loop of continuing to check more names on the roll, it would do an if statement. If there is detected information, display it. Otherwise, keep going. That would be an embedded if statement within this while loop. Repeat until, again, this word specifically isn't within Python. Repeat until and while are actually 2 different variations of the same logic, and we're going to talk about this a bit more in class. It allows you to do a process once and then keep on repeating it while the condition is true. The last type of loop is a for loop. You only use a for loop if you know exactly how many times you want to loop. An example of this in basketball, just use a real world example, would be taking a penalty. Regardless of whether it is you get the first shot in, you always get 2 shots. Or in football, it'd be like a penalty shootout. Regardless of if you get it in or you don't get it in, you get X number of each team gets X number of shots. Yeah, it's when you know exactly how many times you want to loop. We use for loops to go over things called arrays that we're going to talk about, which are like lists. You can use 2 conditions. For I equals 0 to end of array. You would use that. You could use something similar for our compass example for the roll. For I equals 0, so the first element, to the end of the roll. It's when you have a set number of times, rather than a condition like, is password correct? You don't know if the user's going to get the password correct on the first time, the second time, the last time. That's why you'd use something like this, a while loop. If it's a set number or it's a finite number of loops, you can use a for loop. And that's it, guys. That's pretty much loops and choices. When we're talking about the right questions to ask here, remember our focus on is not being correct, but asking the right questions. Do I know how many times I need to loop? Yep, I'm doing a for loop. Do I need to check a condition before looping? Yes, I use the while loop. Not really, I use a repeat until. And like I said, the while and the repeat until can achieve the same outcome if the condition is modified. We're going to go into that in a bit more detail in class.